of time is capital T. So let's put it together. This will now be equal to M, capital M, L squared, T raised to the power minus 2. This one is raised to the power 1. Take it up times T raised to the power minus 1. Write it together. M, L raised to the power 2. This and this will become T raised to the power minus 3. So this expression now is a dimension of power. Can you see the way I've done it for you? So this dimension now, this expression now, rather, is now the dimension of power. Take note of that. Let's consider question number 5. The question says, find the dimension of the following electrical system. Number 1, we have an electric charge. Is that how you call it a charge or electric charge? It's the same thing. And the symbol is Q, which is defined as the product of current I and time, pi t. You remember that current I is one of the fundamental quantities, electric current, I, and the unit is ampere. Remember, the unit of electric current I, once you write a capital A, that is the dimension of current I. Please take note of this. Capital A is the dimension of current I. T, your normal capital T. So this is the dimension of electric charge. Let's move forward. What about electric potential? Well, this one are the exception. Please take note of this. Electric potential, or you can call it voltage. Electric potential or voltage. And this one is defined as power over currents. Power divided by currents. You remember when we are defining power, electrical power, we said P is equal to I V. If you try to make V the solid of the formula, you are going to have P over I. That is how we get this. Electric potential, voltage, V is equal to power over current, P over I. What is the dimension of power? You have to know the dimension of power, then the dimension of time. Power itself is work done over time. I have solved it for you the other time, which is L squared. Are you following me? L squared, then T raised to the power. In fact, we even have it here. L squared. Can you see? Divided by current. And I told you, current, the dimension is capital E. The dimension of current is capital E. So put it together. M raised to the power 2, T raised to the power minus 3, A raised to the power minus, this is raised to the power 1. By the time it moves up, it becomes, can you see that? So what you are having here now is not the dimension of electric potential. So maybe ask, you can have something like this. It looks complex, but it's very simple. So take note of this. Finally, let me quickly take you to capacitance. Capacitance C. How do you write the dimension of capacitance? Capacitance, the formula is charge over potential. Charge over potential, which is equal to Q over V. Okay? And remember that I've given you, please look at this place, electric charge, which is, the dimension is AC. Put it there. V, which is potential. Can you see? Put it there. M, L raised to the power 2, C raised to the power minus 3, A raised to the power minus 1. When you try to analyze this together, let's see, just be following me. We are going to have A, T times, let this one move up, this raised to the power 1, it will become minus 1, this one become minus 2, this one become raised to the power 3, this one become A. Let's put it together. A and A will give us raised to the power 2. T and T will give us raised to the power 4. Then M to the power minus 1. L to the power minus 2. Put it in another way. It's going to be M followed by L followed by T followed by A. This is the dimension of capacitance. This is the dimension of capacitance. Let's consider this question number 6. At what respective value of x, y, and z will the unit of force, the Newton, be dimensionally equivalent to, look at this, m raised to the power x, and then we also have L raised to the power y, and the Z, and the T rather raised to the power Z. Look at this. You may not understand that question, but just be following me. Force. What is the dimension of force? Force is equal to MA. I'm taking it from the beginning now. Dimension of mass is capital M. Dimension of acceleration is T, L, T, raised to the power minus 2. This is now the dimension of force. The power here is 1. For L, the power is also what? 1. Compare it to this. M raised to the power x, L raised to the power y, T raised to the power z is equal to M raised to the power 1, L raised to the power 1, T raised to, we are comparing now. For x is equal to 1. For y is equal to 1. For t, so for z rather, for z is equal to what? Minus 2. So which means 1, 1, minus 2 is what they are asking from you. So if you take the option, this is the right answer. Once you check the dimension of your quantity, compare it to this. So that's what they are asking from you. Question number 7. For which of the underlisted quantities is the derived unit? Look at this. And you are given a particular dimension. M L squared T raised to the power minus 2. The first one is moments. Another one is work. Another one is acceleration. We are not given the option. We are given option A, B, C, and D. Okay? They said, which of these will have this dimension? What I am going to do is as good as this. Quickly find the dimension of each of them. For moments, is force times perpendicular what? Distance. For work, it's the same thing. Can you see what I'm talking about now? I told you that moment and work, they have the same dimension. So don't disturb yourself. Once you have seen moment, you have seen work. Okay? So let's quickly write the dimension of work out. For force, let me take that of work as an for our illustration. For force, again, the dimension of force will give us M, L, T, this is power minus 2, then times distance, which is L. Write it together. M, L squared, T raised to power minus 2. Can you see now? And I have told you that work and moment, they have the same dimension. Automatically from our optional, the option A said, this is 1. It said 1 only. For the second option, which is our B, it said 2 only. Then for option C, it said 1 and 2. Then for option D, 2 and 3. The answer is 1 and 2. I've told you that moment and work, they have the same dimension. Take a look at that. Let's consider question number 8. The physical quantity that has the same dimension as impulse is energy. Option B, momentum. Option C, surface tension. Option D, pressure. The right answer there is momentum. Look at this. From Newton's second law of motion, you still remember that? F is equal to M into V minus U over T over 1 divided by 1. F times T will be equal to